Okay, so yesterday we finished up talking about derivative of a function. Now, the thing is, as you can see from the example we just did a second ago, it's a fairly complex process, right? Give it a second. Come on. There we go. So, if I do something like this, because it's a fairly long process, people started looking for shortcuts. Okay? Now, if something says solve by the limit method, you have to use the limit method. Okay? But if I have a problem like this, I can actually look at this and say, okay, 4x squared minus 5x, my derivative is ax minus 5. Okay? Let's do a different one. What if I have f of x? I'm looking for you guys to try to see a pattern. Okay? What if I have 7x to the 4th plus 3x to the 5th minus 2x to the 4th plus 5x squared minus 3. Oh, 6. I forgot I said 4th and then wrote 5th next. Okay, so for this would be if I did the derivative. And if you want to do it the long way, you can. But 42 x to the 5th. What's the exponent on the variable in this term? 0. Yeah, this is x to the 0, right? So what's the pattern going on here? Okay, so you take your exponent, if it's a simple polynomial, okay? If it's a simple polynomial, you can take your original exponent for each term, times the number out front, and then reduce your exponent by 1. And you have to do that for every term. So 5 times 3 is 15, drops to a 4. Does that make sense? Now, the problem with this rule, and this rule is called the power rule, okay? The problem with this one is it only works for fairly simple polynomials. And it does work for some like some square roots, but if it's as complicated as this one, it's going to fall apart on you. Okay? Actually, no, I take it back. This would work on this one. We can do it on this one. This original problem was what for 41 out of the book? 1 over what? X minus 9. Okay. S squared of x minus 9. There we go. So if I have 1 over the square root of x minus 9, first off, I'm going to rewrite it a little bit. This is actually x minus 9 raised to what power? Negative 1/2. Because it's on the bottom, the 1/2 deals with the square root, right? So then, this negative 1/2 goes where? When I do the derivative. Which the coefficient is what? 1. So the negative 1/2 moves to the front. So I have negative 1/2 out front. Now what happens to my exponent? It goes down by 1. So what's it become? Negative 3/2. Or you can do what's on the way you can see on the board. And for the video's sake, let's see. So that problem. Okay. Okay. Now, the thing is, if there's any kind of weird function going on inside of that square root, if you had something where it was x squared or something like that, it's going to break. There's other rules you'll learn later in calculus for it. The only really safe spot to use power rule is on polynomials. Okay? It will work if you have nothing but linear stuff going on inside of square roots or inside of negative exponents, but it has to be a regular polynomial for nothing strange to happen. If you have functions inside of other functions, that's when issues start to arise. Okay? And actually, I think it would break down if this even had a 2 in front of the x. It would break down even then. It's only because this is 1x that this works. So don't always trust it for problems like this. It is probably safer to go the long route. But would that honestly be on the test?
No.
No. There you go. So, going back to the original problem on here. So I have 4x squared minus 5x. The derivative of that would be 8x minus 5, right? So if I have that derivative is equal to 8x minus 5, and I want to find the equation of the tangent line at x equals 1. What would I do? Well, find your slope. So plug in 1 to what? To find the slope, you're going to plug it into the derivative. So that's going to give you 3. So your slope's 3. What else do you need? The y-intercept potentially. Can I get that from what I have here? Not directly.
Well, when you put x in the equation.
What would that give me? Yeah, it'll give me the ordered pair. So I need the y value here. So I'm going to put 1 into the original equation as well. So 4 times 1 squared minus 5 times 1 gives me negative what? What are you saying? Sorry. 1. I thought I heard negative 9, sorry. My head's really stuffed up and when I coughed, it's hard to hear right now. So, negative 1. So that gives me the coordinate. No, I just couldn't hear you. 1, negative 1, and the slope of 3. How do I get an equation out of that? Choose y equals mx plus b, or you should use the point slope form. Either one of them will work. To review, this is the one honestly a lot of teachers will skip over in Algebra 1. Oops. No, it's not, but it's literally just instead of the center of your circle or ellipse or anything else, that's just a reference point. Plug in your coordinate to x1 and y1, plug in the slope. Yes, you can do y equals mx plus b as well. Go for it. This one, though, makes it kind of easy. Plug in your values, make sure you flip your signs just like you do any other time you have the points like that for any other type of function. Go ahead and do it. I'm hoping you all know that already, so I don't need to reteach that. Y equals mx plus b. Okay. That's the equation of the tangent line at x equals 1. Now that tangent line is constantly changing. That's why we need a function for how its slope is being affected. This is the function for its slope. So when would that have a horizontal tangent line? Well, the slope is 0. So what would I do to find that? Set what equal to 0? We got 4 different things going on here. The derivative. Set your slope value here equal to 0. So you get x equals what? 5/8. Where on this graph would that be visually? Not where's the location of the point, but where would that be? Why at the bottom? Bottom of what? What shape is this? Parabola. So this would be at your vertex. This would be the low point on that parabola because it's a parabola opening up.
Oh, it's literally at your vertex?
That's the x-coordinate of the vertex, yes. Just think about on a parabola, the only spot that's going to have... All right. Just the x value is fine. If you put a point, I'm not going to count it wrong. Alright, so, how would I find the derivative for this one? So she's writing exponential as an exponent form instead of that square root form.
And then, you do 1 half times x plus 1.
What would your exponents become?
Negative 1 half.
Negative 1 half, because you subtract 1 from the exponent. It drops by 1 whole. What about the plus 1? Why can't I just throw it out? Why does it become 0 every single time? Because the exponent's 0. Think about this visually. What does the plus 1 do to this function? Right, you have square root of x, right? Square root of x is just this curve, roughly. All this plus 1's doing is moving up or down. Add 7, subtract 12. Whatever it is, all you're doing is moving it. Is that going to change your slope? No, it's just changing the position of it. The slope's still going to be the same. So that's why all these constants will completely disappear. You do need to clean this up, though, a little bit. What would it look like? One over 2 square root of x. The negative is going to move the x down to the denominator, along with the 2. It's already there. The 1 half is going to make a square root. So there's your formula. Then what's your slope at the 4, 3? Yeah, so plug in 4 here, square root of 4 is 2. So 1/4. And at 9/4 gives you 1 over 6. Questions? Okay. One last thing, just to practice it a little bit more. And the derivative shortcut, technically, you should stick to polynomials for it. It will work on some square roots. Okay? If there's anything but just an x, or an x plus one number under that square root, don't use it. Okay? So if I just have f of x equals a number, then what's f prime? 0, because if y equals a number, it's just a horizontal line, right? If I have f of x equal to ax plus b, what's my derivative going to be? A. It's a slope. It's a straight line. What if I have ax squared plus bx plus c? Plus b. The 2, remember, comes down to the front, is multiplied times the whole term. The exponent reduces by 1. And for here, the bx, well, there's a 1 power here. 1 times b is still b. And it goes down to 0 for the exponent. So then we're going through this real quick. What would be your derivative of 4? 0. What's your derivative of 5x plus 10? Negative 3x squared plus 6x minus 2? 1 over x. What do you have to do first if it's 1 over x? X to the negative first. Then do your derivative. So you have negative 1 out front and x to the what? Negative 2. Now clean it up. Because remember, you drop your exponent by 1. 1 down from negative 1 is negative 2. So what's that going to look like when you simplify it? Sorry, what? I'll just, the negative is just going to flip it. I don't have anything square rooted. Negative 1 over what? X squared. And square root of x? Square root of x, you get what?
1/2.
Clean it up.
1 over 2
1 over 2 square root of x. Okay. I got a little bit of time. Take a look at some of those problems, okay? On the test and on the quiz, it will say solve using limits, or find the derivative using limits, or just find the derivative. If it just says find the derivative, I don't care what method you use. If it says find using limits, you have to do the limit as h approaches 0 of the difference quotient. Okay? The rest of the